Hello gardeners, welcome to the Living Soil Lab. What if I told you there are supercrops out there that thrive in conditions most plants would wither and die in? These aren't just obscure plants, they're powerhouse foods that could be the key to sustainable living and food security for generations to come. Join me as we uncover the surprising secrets of 5 extraordinary crops designed to withstand whatever the future throws at us. The past few years have delivered a wake-up call that many of us are still processing. In 2024, we witnessed unprecedented droughts that devastated wheat crops across major producing regions, sending grain prices soaring and creating ripples of food insecurity that reached even wealthy nations. Then 2025 brought catastrophic flooding that wiped out rice paddies and vegetable production across entire regions, reminding us that our modern food system remains shockingly vulnerable to weather disruptions. These aren't isolated incidents but symptoms of a larger pattern where traditional growing regions can no longer rely on the stable, predictable conditions that agriculture has depended upon for millennia. Food resilience means more than just plants that can survive. It means crops that can actually thrive and produce meaningful yields even when conditions are far from ideal. We're talking about plants that can handle drought one season and excessive rain the next, that can grow in poor soils without extensive amendments, and that maintain their nutritional value even under stress. The remarkable thing is that these resilient crops already exist, and, many of them were cultivated by human societies for thousands of years before we became dependent on the narrow range of species that dominate modern agriculture. Beyond corn and wheat, the unsung heroes, let's start with amaranth, a crop so resilient it was considered sacred by the Aztecs and formed a cornerstone of their civilization's food security. Amaranth is what botanists call a C4 plant, meaning it uses a more efficient form of photosynthesis that allows it to thrive in hot, dry conditions where other crops simply shut down. When temperatures soar above 95 degrees Fahrenheit, conditions that cause corn and wheat to stop growing, amaranth actually accelerates its growth, turning brutal heat into an advantage. The plant's deep taproot system, often reaching 4 to 6 feet into the soil, allows it to access moisture that shallow-rooted crops never touch, making it remarkably drought-tolerant once established. But amaranth's resilience goes far beyond just heat and drought tolerance. This crop can grow in soils ranging from sandy to heavy clay, can tolerate pH levels from slightly acidic to alkaline, and actually produces higher protein content when grown under stress conditions. The seeds are tiny powerhouses containing all 9 essential amino acids, making amaranth a complete protein source that rivals animal products, while the leaves can be harvested as nutritious greens throughout the growing season. I've grown amaranth in garden beds that were essentially hard-packed clay with minimal organic matter, conditions where I wouldn't even attempt most vegetables, and watched it produce 6-foot-tall plants loaded with seed heads by late summer, with almost no care, beyond initial establishment watering. Our second resilient powerhouse is the sweet potato, a crop that might seem commonplace but possesses extraordinary survival characteristics. Sweet potatoes can produce meaningful yields in soils so poor that most crops would barely germinate, and they're remarkably tolerant of both drought and occasional flooding once established. The vining growth habit allows sweet potatoes to cover ground, quickly suppressing weeds and protecting soil from erosion, while those underground tubers steadily accumulate calories and nutrients. What makes sweet potatoes particularly valuable is their incredible storage capability combined with nutritional density. Properly cured sweet potatoes can store for 6 months or more without refrigeration, providing calories and nutrition through winter months when fresh produce is scarce. I've seen gardeners produce over 100 pounds of sweet potatoes from a single 4-by-8-foot bed, enough to provide meaningful caloric contribution to a family's diet for months. Now, moving into crops that show, even more remarkable adaptability, we encounter quinoa. This is a pseudo-cereal that actually originated in the harsh, unpredictable climate of the Andean highlands, where temperature swings of 40 degrees Fahrenheit in a single day are, believe it or not, pretty common. Quinoa has evolved some specific biological mechanisms that let it handle both freezing temperatures at night and, well, intense solar radiation during the day. That makes it one of the most versatile crops for regions that are experiencing climate instability. The plant produces saponins. These are bitter compounds that coat the seeds and protect them from birds and insects, so it kind of reduces pest pressure all on its own, without any human intervention. The root system of quinoa really deserves special attention because it, exemplifies the kind of climate adaptation we need in resilient crops. Quinoa develops both shallow lateral roots that capture surface moisture from light rains and deep taproots that access groundwater during dry periods. So essentially the plant has two water-gathering strategies depending on the conditions. This dual-system approach allows quinoa to maintain growth through drought periods that would kill crops with only shallow root systems. In trials across diverse climates from sea level to high altitude, from arid to humid conditions, quinoa has demonstrated the ability to produce viable harvests. Nutritionally, quinoa offers another complete protein source with all essential amino acids, making it valuable for food security beyond just calories. Our fourth resilient crop is the cowpea, also known as the black-eyed pea, a legume that has sustained populations across Africa and the American South through some of the most challenging agricultural conditions imaginable. Cowpeas are extraordinary in their ability to fix nitrogen, even in depleted soils and under drought stress, conditions that cause most legumes to abandon nitrogen fixation. This means that cowpeas not only feed themselves in poor soils but actually improve those soils for subsequent crops, making them invaluable for building food security in degraded landscapes. The plant's heat tolerance is remarkable, with optimal growth occurring at temperatures between 80 and 95 degrees Fahrenheit, ranges where many crops struggle. The drought tolerance of cowpeas comes from several adaptations working together. The plant can close its stomata during the hottest parts of the day to conserve moisture, while still maintaining enough gas exchange to continue photosynthesis. The root system is efficient at extracting water from soil, and the plant can actually shed some of its leaves during extreme drought to reduce water demand, then regrow foliage when moisture returns. Beyond their growing resilience, cowpeas offer tremendous flexibility in how they're used. Young pods can be harvested and eaten like green beans, mature seeds can be dried for storage, and the leaves are edible and nutritious, harvested as greens in many cultures. The future of your plate, the ultimate resilient crop. For our fifth and arguably most impactful resilient crop, we turn to Moringa, often called the miracle tree for good reason. While technically a tree rather than an annual crop, Moringa deserves inclusion because of its exceptional ability to produce nutritious food under conditions that would be absolutely prohibitive for most crops. Moringa grows incredibly fast, reaching 12 to 15 feet in its first year even in poor soil, and it produces edible leaves, pods, flowers, and seeds, making it a multi-dimensional food source from a single plant. The leaves contain exceptional concentrations of vitamins A and C, calcium, iron, and protein with nutritional density that surpasses most vegetables gram for gram. What makes Moringa the ultimate resilient crop is its ability to withstand multiple stressors simultaneously. The tree thrives in hot, arid climates where daytime temperatures regularly exceed 100 degrees Fahrenheit and rainfall is minimal and unpredictable. It grows successfully in soils ranging from sand to clay, tolerates salinity that would kill most plants, and actually prefers poor soil over rich, amended beds. The deep taproot, which can extend 20 feet down in some soils, allows Moringa to access groundwater that surface-dwelling crops never reach, making it practically drought-proof once established. In regions facing desertification or water scarcity, Moringa offers a way to continue producing nutritious food when almost everything else fails. The potential for widespread adoption of Moringa is just tremendous, especially in tropical and subtropical regions where, food insecurity is often most acute. The tree can actually be harvested continuously throughout the year in frost-free climates, with leaves being picked regularly to encourage new growth. It's basically like having a perpetual vegetable garden, but on a tree. For gardeners in temperate climates, Moringa can be grown as an annual. You just plant it in spring and then harvest it aggressively through summer, before frost, kills it back. Cultivating your own food future really starts with understanding these resilient crops, and while that's definitely valuable, the real power comes from actually growing them and seeing firsthand how they perform under challenging conditions. So, starting your journey means first assessing which of these 5 options best matches your climate, available space, and of course your food preferences. For hot, dry climates, Amaranth cowpeas and Moringa are obvious choices that will thrive with minimal water once established. In regions with more variable conditions, sweet potatoes and quinoa offer the adaptability to handle whatever each season brings. Sourcing seeds or planting stock for these crops has actually become progressively easier as more gardeners discover their value. Amaranth and quinoa seeds are, widely available through seed companies that specialize in heirlooms and unusual crops. Sweet potato slips can be purchased in the spring from garden centers, or you can even produce your own by sprouting organic sweet potatoes from the grocery store. Cowpeas are, increasingly available as gardeners rediscover this traditional crop, and Moringa seeds can be found through tropical plant specialists. Perhaps most importantly, all 5 of these crops are relatively easy to save seed from, making them truly sustainable food sources that don't require annual seed purchases. This seed-saving capability means your food security actually increases over time as you build up reserves of adapted seeds specifically suited to your conditions. I encourage you to choose one of these 5 resilient crops to trial this coming season, dedicating even just a small bed to experiencing firsthand how differently they perform compared to conventional vegetables. Document what you observe and share your experiences with other gardeners in your community. Subscribe to the Living Soil Lab for more explorations of resilient crops, sustainable food production techniques, and practical strategies for building genuine food security in an uncertain world. Share this guide with friends and family who want to take concrete steps toward greater self-reliance. Together, we're not just growing food, we're cultivating resilience that will serve our communities for generations to come.